Algebra students, in this lesson, lesson 18, we're going to be talking about solving one-step equations, the simplest type of equation in all of algebra, by adding or subtracting the two simplest operations in all of algebra. So I don't expect that this lesson is going to be a hard lesson, but what it is, it's going to be a fundamental lesson. What you learn in this lesson is going to apply to like all other lessons after this in the course. Because we're going to be learning a lot about equations, and there is one simple goal that you have in solving any equation that we're going to talk about in this lesson. Before we start though, let's take stock of where we've been so far this year. We haven't been talking about equations yet. We've been talking about expressions, expressions, expressions. Expressions are mathematical statements that might include different operations, plus, minus, times, divided by. They might include variables and values. Okay, we might have those values and variables separated into different terms. We've talked about coefficients in expressions. Those are the numbers that multiply a variable. We've talked about constants in expression. That's any value in an expression. And we've talked a lot about variables. The one thing we haven't talked about yet, though, we haven't done yet, is equal signs. We haven't made our expressions into equations. And okay, that's a bit of an overstatement because we have done some equations so far this year. But what we're going to learn now is we're going to learn how to solve equations in a very systematic and straightforward way. And that's where this lesson starts. And we're going to start simple and we're going to build up to difficult. Okay, so get ready because as we continue through the year, you're going to learn more and more and more about equations, and the things we do in this lesson are going to seem really basic and elementary, but it's important to start here, and it's important to be thinking about how we're actually solving these equations. I'm going to tell you this. When you see an equation in this lesson, you're probably going to just know the answer intuitively off the top of your head. You're not even going to have to do the steps that I'm going to show you, but I'm just going to tell you, you have to do the steps with me, okay? You have to pay attention what the steps are, because if you don't, when we get to lesson 50, lesson 60, lesson 70, you're going to be lost when it comes to solving equations because you didn't pay attention on lesson 18. And you knew intuitively how to do in this lesson what you will not know how to intuitively do when you get to like lesson 50 or lesson 60. Okay, those ones, if you don't know what the steps are and why we're doing the steps, it's going to get really hard. So pay attention to what we're doing here. I promise you it's going to help you in the future when these sorts of things come back again. All right, the first thing we're going to do is we're going to define what an equation is. It's a statement that uses an equal sign to show that two expressions are equal. We have an expression on one side, we have an expression on the other side. And remember, expressions can contain variables. They can contain constants, coefficients, terms, all of those things, operations, okay? Those are all part of expressions. The only thing that's different about this lesson is now we have an equal sign between two expressions. The solution of an equation in one variable is the value of the variable that makes an equation true. How many variables do we have in these equations? One, okay? So there is a single value that makes an equation true. In the future, we're going to be working equations with two variables, and we're going to find that there is a whole series of values that make an equation true. Okay, but here, there's just going to be one value. Like I said, simplest type of equation, simplest type of operation. That's what we're going to be doing in this lesson. And just want to show you this image from the book. When we're dealing with equations, we're actually dealing with balancing, okay? So the equation x plus 6 equals 9 is like a balance. And we have x plus 6 on one side and 9 on the other. And the two things on either side of the equal sign balance each other. So what does that mean I can do? If I take something off the balance on one side, can I still balance the other side? Yes, as long as I take the exact same thing off the other side of the balance. If I add something to one side, can I still balance with the other side? Yes, as long as I add the same thing to both sides of my balance. And that's what the key is here. Whatever you do to one side of an equation, you have to do to the other. That is the most important thing I'm going to say in this lesson. So if you're taking notes, write that down. Whatever you do to one side of an equation, you have to do the same thing to the other side. Now, what is an equivalent listen to those two prefixes in both these words. Equivalent equations. Equivalent equations are equations that have the same solution set. X plus 6 equals 9 is an equivalent equation to x equals 3. And we're going to see through the two properties we're going to learn next how you can change x plus 6 equals 9 into x equals 3 in a very systematic way so that you always know that you're dealing with equivalent equations. What we're going to be doing when we solve equations is we're going to be writing a series of equivalent equations until we get an equivalent equation that has the variable on a side by itself. That's what we're trying to do. Get the variable on a side by itself, the equal sign, and then the value that the variable equals. Now, what are our two tricks, the two tools in our tool bag? Well, here's one of them. The addition and subtraction properties of equality. And the first is the addition property. If I add something to one side of an equation, I can add the same thing to the other side, and the equation remains true. 2 equals 2. Let's say I add 3 to the left side of this equation, and I get 5. How do I make the right side equal? Well, I have to add 3 to that side as well. 5 equals 5 is still true. 2 equals 2 is true. 5 equals 5 is true. In general, if I have A equals B, if I add a number C to one side, I could add that same number to the other side. So if A equals B, A plus 2 equals B plus 2. As long as I add the same number to both sides, I'm not changing the equation in any substantial way. Another way to think about it, I'm creating an equivalent equation by adding the same thing to both sides. The same is true of subtracting. If I because addition is subtraction, right? If I or subtraction, should say it the other way. Subtraction is addition. If I subtract the same things from both sides of an equation, I'm still going to have an equivalent equation. 10 equals 10. Subtract 4 from both sides, I get 6 equals 6. It's still true. 6 equals 6. Okay. If I just did it to one side, 10 minus 4 equals 10, then I get 6 equals 10. It's no longer true. But if I do it to both sides, I maintain the truth of my equation. Now let's take a look at the general form. A equals B, A minus C equals B minus C. So if it's like A minus 5 equals C minus 5, equals B minus 5, I mean, because I'm subtracting the same thing from both sides, I have an equivalent equation. I haven't substantially changed it. All right, now, let's just take a look at what we're doing when we use equivalent equations. If I add 2 to both sides, notice my balance is still balanced. And that's what we're doing. We're just going to do the same thing to both sides of the equation. When we work the practice problems in the next video, I'm going to be doing a lot of that. I'm going to be talking that through. We're going to do the same thing to both sides of an equation. Now, one other thing you need to know, inverse operations are operations that undo each other. There's one inverse operation we're going to be using in this lesson, and then one we're going to tuck away for the future. Addition undoes subtraction. Subtraction undoes addition. One of the things we're going to do, let's go back up here. X plus 6 equals 9, this equation right up here. How do I get x on a side by itself? That's what I want to do. I want to get x on a side of the equal sign by itself, and then I'll know what x equals. Well, right now there's a plus 6 with the x on the left. How do I get rid of that plus 6? I could use the inverse operation of addition. It's plus 6. How do I get rid of it? I could take minus 6. But I can't just do minus 6 to the left side of the equation. I have to do minus 6 to both sides. So x plus 6 minus 6 is just x. 9 minus 6 is 3. I'm left with x equals 3. We'll be studying that little move in the next video in depth. So tune into the next video where we do some practice problems involving this fundamental thing we're going to be doing in algebra, where we do the same thing to both sides of an equation.